Hey everyone, welcome back to Smart Architectural Programming, the channel that helps you build smart software from the ground up. If you're reading Intro to Java book, this video is your perfect companion to that chapter on methods. And if you're watching this on our channel, not related to the book, this is part of our playlist on Introduction to Java, basically. So without further ado, let's dive into methods. So today we're diving into why methods are a must-have tool in your Java toolbox. We'll cover how they help you with control flow, abstraction, and how they reduce code duplication. Ready? Let's break it down and understand exactly what methods are. So a lot of you might be wondering, what are methods in Java, right? And that's a very legitimate question. So let's step back a little bit and imagine writing a Java program and stuffing every line of logic into the main method. It's like building a skyscraper without blueprints, without foundations, messy, error-prone, and nearly impossible to maintain. Methods are also known as function under other language, and this is critical here. If you're coming in from another programming language, you need to understand that methods are just functions. They're isolated modular sections of code focusing on a certain logic. It lets us split program into smaller manageable pieces, each piece a module that handles one specific task. Think of them as self-contained blocks that each do one job really well and only do just one job. Keep that is integral to method best practices, just doing one single specialized task. It's generally speaking, if you want an analogy for this, it would be like, imagine that it's a restaurant kitchen, right? One chef handles the grilling, another preps vegetables, someone else does the plating, and methods let your code work the same way, efficiently, with clear responsibility. One doing one single task and doing it well, so it combines together in a whole into a one beautiful course meal that is presented to you, basically. So now that we understand that, we need to understand control flow in methods, right? What is basically control flow in reference to methods? How do we control our flow of our softwares when we're leveraging methods? When you call a method in Java, the program jumps to that method, runs the code inside it, and then comes back where it left off. So you mention a method, it jumps to that block of code, runs that block of code, whatever information you wanted to compile or whatever result you needed, that's sent back to where you called the function, and it continues running the code, basically. So this flow helps you keep your code clean and lets you focus on what your program is doing, not just how. It also helps you with debugging. If something breaks, you know where to look at for it. So we need to understand that some methods return values, like we have a function called int add function, which is just basically a simple function in Java that adds two integer values, right? So if you have this int add function, presumably, and don't mind my handwriting here, it's a really difficult tool to use and write, basically. So let's presume this is just int add, and within that we have two integers a and b. That is the values that this function or method needs to take in before it's able to run. While others just perform actions like printing something out. That's the difference between returning and void methods, basically. So this method here is going to return you values because we're asking it to add a and b and return the value back to us, to the main function. But this is basically not a void function. This is a return function. There are some functions called void functions, which basically just do a task in isolation, like print something, do some action that is going to help what your logic is on the main side, but it does not necessarily, the main program does not depend on that void function to continue and do the major the important aspects of the program and its logic. So that is what you need to understand about control flow controls in methods in Java, basically. So another aspect to, and this is probably an important aspect to most functions or methods as we call them in Java, is abstraction, right? So imagine this, you want to have you run a calculator. You write, I want to add 1 plus 1 and press equals 2. You press 1 plus 1 and press equals to. The plus is the function, and the equals to is the result that you're looking for. You don't know what happens behind the scene. You don't care what happens behind the scene. You just get the result that you need. 1 plus 1 equals to 2. So the complexity behind that calculation, the hardware, the software, all of that is not visible to you. But you know, if you do this, you get that answer that you're looking for. So methods are similar like this. Like when you use some method like sort array or get user input, you don't need to worry about how it works. You just need to know that it does work, basically. That's abstraction. By abstracting logic into methods, you make your code easier to read, easier to test, and easier for teams to collaborate on. So that is what abstraction is in simple terms. So how would, why would, like, other than abstraction and the other thing that we discussed earlier, why would we use methods, and why not just, again, as usual, stuff everything in the main coding logic? It's very, very important because we need to reduce code duplication. That's the most important aspect here. The dry principle of coding is a very essential principle for programming. Do not repeat yourself, right? And the reason for that is if you write repeat code, there's something very, very fundamentally wrong with your coding practices and principles. So let's be real. Copy pasting code is tempting, but it's always going to be a trap. It's always going to be problematic, and that's why the dry principle exists. When you use methods, you write a piece of logic once, and you can reuse that logic wherever it needs. For example, the calculator example, the addition process that I talked about. If we were coding a calculator, you would want to just write it once and reuse the add function over and over again, or method over and over again, instead of coding it every single time that it's called. And that's going to cause problems because that it's not clean, and it makes your code messy, which means you are more prone to make more mistakes. And so using methods is just smart. It's just common sense and smart. Fewer bugs, faster updates, and more consistency on how you implement your code. So if you need to change the welcome message in your app, just update in one single method. Done. You don't need to redo it over and over again manually across the code. Make sure you update the welcome message in your single method, and it updates it across your code. So I think we have covered a lot here today. So let's recap methods in Java and help you basically understand exactly why they're, the crux of them. So we understood how they help you organize your code, how they help you control the flow of execution of your software, how they help you abstract away complex logic, and what abstraction is. Honestly, that's an important aspect to understand. It helps you understand that you need to eliminate duplication and simplify maintenance, and implement the dry coding principle that has been in existence for a long time, and there's a reason for it to exist. Do not duplicate your code. Do not repeat yourself. So think of methods as a foundation of clean, maintainable code. The more you use them wisely, the more powerful your program will become. So if you're following along our introduction to Java book from Smart Architecture Programming, now's the time to experiment with your own methods. Try creating one today. Like this video, tap like, hit subscribe, and don't forget to turn on notifications so you don't miss the next Java lesson. Until next time, keep coding smart and keep hustling and becoming the best programmer you want to become out there.